Now we start impulse of a force. What is the impulse of a force? So basically, according to the first law of motion, any unbalanced force changes linear momentum of the system. That is, basic effect of an unbalanced force is to change the momentum. Now we can write by Newton's second law of motion. You know that F is equal to dp by dt. So by this formula, I can write F into this dt is equal to d. So this F is the force, dt is the time, dp is the change in momentum. So force into this time is called as impulse. So where we can write F into this dt is impulse. So basically impulse is a force multiplied by time, and dp is equal to change in momentum. dp is change in momentum. So here we can write impulse is equal to change in momentum. So here we get this. Also, the same formula we can write by Newton's second law also F is equal to ma. So F is equal to this m, as it is a, we can write final minus initial velocity divided by t. So t I can shift to this side. F into t is equal to F into t is equal to this m I multiplied inside mv minus m. So mv is the final linear momentum. Mu is the initial linear momentum. So it gives us change in momentum. Linear momentum we are talking about here. So linear momentum, and this is impulse. So here we can write impulse is equal to change in momentum. Same equation we get here. So you already learned in the chapter number 1, dimensional analysis. The impulse and momentum having the same dimension. The reason is this. Now let's see necessity of defining impulse. As discussed above, if force is a constant over a given interval of time, or if we know how it varies with time, we can calculate the corresponding change in momentum directly by multiplying force and time. So listen, so momentum, change in momentum we can find out by impulse. By multiplying force and time, we get change in momentum. But however, in many cases, appreciable force acts for extremely small interval of time. In some cases, force is acting, means larger force we can say, acting for very small interval of time or for fraction of second. So that time it's very difficult to find out impulse. However, change in momentum due to this force is noticeable and can be measured. This change is defined as impulse. Now let's see some real life examples. When we hit a ball with a bat, hitting ball with bat. In that time, the ball and bat is in contact with fraction of second only. So in that case, it's very difficult to find out impulse because larger force is acting for very small time. So we can find out change in momentum, we get impulse. Giving a kick to a football is the same example. Hammering a nail is also similar to this larger force for smaller interval. Bouncing a ball from hard surface. In such cases, the time for which these forces act on respective object is negligibly small, mostly not easily recordable. However, the effect of this force is a recordable change in momentum of that. So it's very difficult to find out impulse, but we can find out the change in momentum, and change in momentum and impulse are same. So thus it is convenient to define change in momentum itself as a physical quantity, and which is equal to the impulse.